Welcome back, dear students. Now we will see video number 19 of the same chapter, that is chapter number 4. In this video, we will discuss the motion of a charge in a magnetic field. Let us say, suppose this is a magnetic field which is perpendicular to the plane and going inside. Okay, so magnetic field is perpendicular to the plane and it is going inside. Okay, now let us consider a charge Q. This is a charge Q which is moving with velocity v. Right? So this is a uniform magnetic field B which is perpendicular to the plane and going inside. Right? So the magnetic force acting on this charge is given by previously we have seen F is equal to Q V B. Here we have taken theta is equal to 90 and you know that sin 90 value is equal to 1. Why? Because magnetic field is perpendicular to the plane and charge is going, so there is angle 90 degree between velocity of a charge and uniform magnetic field B. Got it? Give it equation number 1. Right? So when this charge is entering into a uniform magnetic field, right, because of this Lorentz force, the charge is moving in a circular path, right, like this. Okay, the circular path of a charge is shown in our figure with a red color. Why circular path? Because of this force, and that force is perpendicular to V, perpendicular to magnetic field B, and because of this reason it having a circular path. Right? If the charge having circular path, then there is a centripetal force act on a charge, and that force is given by F is equal to m v square by r. So what is m? M is nothing but mass of charge, and r is nothing but radius of that circular path of a charge. Give it equation number 2. From these two equation, C for common, C for compare, as we know, from these two equation we will have equation. Which equation? That is Q VB is equal to m v square. So v square is v multiplied by v upon r. So 1v will cancel out. Okay, then from this find out the equation of r. What is r? Radius of that circular path of a charge. So r is equal to, make a subject r, Q and B will come downside. So it is mv by qb. What is m? Mass of a charge, constant. What is q? Charge, constant. B, it is uniform magnetic field, so obviously it is also constant. Here mv, what is mv? mv is nothing but momentum of a charge upon qb. So from this equation it is clear that as velocity increases, obviously momentum increases, and as momentum increases, the radius of the circular path also increases. Means, in short, this equation shows that as radius increases, velocity of that circular path of charge also increases. Hence, momentum, that is mv, is also increases. Okay, give it equation number A. Once again, a charge is moving with velocity v, so magnetic force acting, that is qvb. Due to this magnetic force, when charge is entering into a uniform magnetic field, it having a circular path, so centripetal force. Compare both equation, find out the equation of R is equal to mv upon qb. Got it? Give it equation number A. Equation number A shows that, what it shows, that is, as radius increases, the velocity of a charge also increases, and momentum, that is mass multiplied by velocity, is also increases. Okay, from this we have to keep out equation of velocity, that is v is equal to qb multiplied by r upon m. Right? It will help you later on. Let it be. Give it equation number 3. Keep it in one side. Okay? But, what but? But we know that what? V is equal to R omega. Put it here. So our equation becomes R is equal to M multiplied by, instead of V, we are placing R omega upon QB as it is. So R will cancel out. Make a subject omega. So you will have omega is equal to QB upon M. But what is omega? Omega is equal to 2 pi f. What is f? Frequency. Or you can write 2 pi by t. Okay? So put this value. Omega is equal to 2 pi f here. So you will have 2 pi f is equal to qb. And from that, f is equal to, make a subject f is equal to qb, charge constant, b magnetic field constant, upon 2 pi. It is a numerical value. It is also constant. So give it equation number B. Right? From these two equation, which equation? F is equal to QB upon 2 pi. So from this equation, we come to know that QB, 2 pi, all these things are constant. So you can say that F, what is F? F is nothing but frequency of that charge. that frequency of charge remains constant. Okay, so now you have to merge, you have to combine both equations, that is equation number B and A. How? Let us see. When a charge is moving in a uniform magnetic field B, which is perpendicular to the plane and going inside with a velocity v, then as radius increases, velocity or momentum increases, but frequency of the charge remains constant. Once again, students, let us say, when a charge q is moving with velocity v in a uniform magnetic field B, which is perpendicular to the plane, then as radius increases, velocity as well as momentum increases, but the frequency of the charge remains constant. Right? On this fact, that is on the equation A and B, there is a one device which is constructed. It is known as cyclotron. Right? So, what is the principle of cyclotron? The principle of cyclotron, as we have seen, as I have discussed, that is from A and from B. So whatever I spoke, it is the statement. That statement you have to write by your own. Once again I am speaking. Listen carefully, okay? When a charge q is moving with velocity v inside the uniform magnetic field, which is perpendicular to the plane and going inside, then as radius increases, the velocity and momentum of a charge increases, but the frequency of a charge remains constant. Right? So this is the statement of principle of cyclotron. Okay? What is cyclotron? Right? Cyclotron, it is a device which is used to accelerate. What to accelerate? Charge. Right? Once again, its principle finished. Now let us see its use. Cyclotron is used to accelerate a charged particle. Right? These highly accelerated charged particles are used to study the characteristics of nuclei. It is its first use. Once again, cyclotron is used to accelerate electric charge. This highly accelerated charge is used to study the characteristics of nuclei. Second, to implant ions on any metals. Third, in a medical science. For an example, this highly accelerated charged particle is used to destroy the cancer, the germs virus of cancer, as well as to break the stone in a kidney. Okay, this is its use. That use is given in our textbook on page number 141 and 142. Okay, so the use of cyclotron is on page number 141 and 142. Right? I am not writing here. Why? Because you must have to go through the textbook. how the cyclotron is constructed, how it works, let us see. Okay, before that you have to look once on the principle of cyclotron. Let us take few seconds. Okay, now let us see cyclotron. So this is the cyclotron. Cyclotron is made up of two metallic discs of a circular shape. See, this is the metallic disc of circular shape. It is of D shape, right? So it is disc number 1, and it is disc number 2. Okay, so it is disc number 1 and disc number 2. These two discs are placed in a uniform magnetic field B. Okay, here at the center there is a charge Q which is to be accelerated. Is it? Cyclotron is made up of two large metallic discs of which shape? D shape, which is known as Ds. Spelling is very nice. D-E-E-S. Ds. And these two Ds are connected with an oscillator. And the frequency of oscillator is given by FO. Have a look. Cyclotron, two metallic discs, it is known as DEES. It is placed in a uniform magnetic field, right? Both discs are connected with an oscillator, and the frequency of oscillator is FO. Here at the center there is a charge Q which is to be accelerated. So this is the construction of that cyclotron. Now before starting we have to do one thing. What to do? You have to adjust frequency of oscillator must be same as frequency of C cyclotron. Previously we have seen the equation of Fc. It is here C. That is frequency of electric charge, or you can say that frequency of cyclotron is equal to QB upon 2 pi. So both the frequency, that is frequency of a charge as well as frequency of oscillator must be same, and this condition is known as resonance condition. Okay, so you must have to maintain the resonance conditions by selecting the frequency of oscillator. One more thing, right? You must have to maintain uniform magnetic field inside. Means the D's must be in uniform magnetic field. Not only that, the electric field must be absent. Okay? Then, third point, you have to write you have to remember. Okay, as per principle, this is a charge. With the help of oscillator, you have select one frequency, and that oscillator, it is adjusted in such a way that the polarity of both the D's must be alternative. That means inverse. Okay, if D number 1 is positively charged, at the same time D number 2, there must be a negative charge. Okay, then according to the principle, this is a charge, it is moving with velocity v. Now it enters into the uniform magnetic field, so it having circular motion, and as per principle, as radius increases, velocity increases. As velocity increases, its momentum also increases. So, right, with the help of deflection plate, this highly accelerated charged particle is taken out, and these highly accelerated charged particle are used in a various way that we have seen earlier. For an example, once again, to study the nuclei, second, to implant ions, and in medical field. Okay, so this is the construction as well as working of this oscillator. But dear students, this cyclotron having some limitations, right? Limitations are not there in our textbook. So for that limitation, we have to take a help of GSEB textbook. So which are the limitation of cyclotron? First limitation, that is frequency of oscillator must be equal to frequency of cyclotron. If the frequency of oscillator become less than frequency of cyclotron, means this is our prime condition. If FC, frequency of cyclotron, become more than frequency of oscillator, then in this case the disk must be blast. Second, what to second? Right, second limitation is it is difficult to maintain uniform magnetic field. Right, so this is its second limitation. Right, that means here you must have to maintain uniform magnetic field inside the disk. But what is the problem? The size of disk is too large. So this difficulty arises due to size of disk. Right? And it is very difficult to maintain the uniform magnetic field throughout the disk. Why? Because the size of disk are too large. Third one, this cyclotron is used to accelerate charged particle, but this charged particle must be heavy. For an example, proton. Or you can say that it is used to accelerate positive ions only. It do not accelerate that light charges, for an example electrons and neutrons. And for that we will study in future, instead of cyclotron we have to use synchrotron, right? Again name synchrotron. Why synchrotron? Because cyclotron is used to accelerate positive charge only, right? So this is about its working. Okay, so again I am telling you, this is a very nice topic, and the question from this topic is very important. Which question? Explain the principle of cyclotron in detail. Or there is one more question, explain construction as well as working of cyclotron. So many times there was a third question, give the limitations as well as uses of cyclotron. Okay, so from this topic, from today's video, there are 4 questions. Okay, so their questions you have to attend from our assignment. Thank you.